Over to you, James.
Thanks. So as Nathan said, I'm going to be telling you predominantly about some work we did mostly last summer as part of a CEI seed corn funded project. So it's kind of as a bit of background to this project. In many degree programs in physical and life sciences, laboratory practical work is an integral part. And typically a laboratory practical will be accompanied by some sort of note-taking to actually record what goes on during the session, and that's generally followed up by some sort of a report that the student submits afterwards. So the reports have a number of purposes, so they can be there to kind of prompt the student to think about what they've done in the lab session. It can be an opportunity for a student to apply theory, which may have been taught in parallel in lectures. The lab reports are also a good opportunity to give students some practice at writing and record keeping to professional standards, for example, as a kind of a journal style write-up. So the lab reports can also be formatively and summatively assessed. So there's kind of two aspects to this. There's kind of assessing the actual record keeping and reporting and analysis of data. But we can also, particularly in chemistry, actually kind of use the practical reports and the data that they contain as a sort of a proxy for what the student has actually been doing in the lab. So the student's data is an indication of kind of the quality with which they have actually performed the piece of practical work in the laboratory. So electronic lab notebooks and record keeping has been kind of widely adopted in industry, and the typical lab notebook system allows input of both text and it allows capturing of data, digital data that's created during an experiment. So there are a number of advantages to using a digital system. For example, searching, collaborative working in groups, and also particularly from the perspective of industry, and particularly the pharma industry, which is highly regulated, security, kind of access rights, time stamping and digitally signing documents. So lab notebooks have been less widely adopted in academia, particularly in a sort of a teaching context. So many of the products have been developed with the need of industry in mind rather than teaching. There are some cost implications and also IT requirements. So we are interested in seeing whether there are any products out there, either open source or commercial, that could be particularly applied as a replacement for the kind of the paper-style lab reports that we were typically using in our practical courses in the School of Chemistry. So this was the subject of a CEI seed corn project last summer, and the focus of the project was to evaluate various different systems, and the evaluation was done by a member of staff, myself, and a third-year chemistry student, Chris Algar. And we had a variety of considerations when we were evaluating the different systems. How flexible do the various notebook and portfolio systems allow us to create student reports? Can we accommodate different styles of lab report? Is there actually any pedagogic value to using these tools? What are the implications for staff and student workload, and also cost and IT requirements? So I'll just show a very quick slide here, some of the things that might go into a typical chemistry report. So we might have, for example, digital images, raw data in the form of spreadsheets, graphs, equations, and obviously being chemists, we love our chemical structures as well. We were also very interested in seeing how these online tools could facilitate the return of feedback to students, and also particularly for our Year 1 and Year 2 classes, it's useful to be able to create some sort of a template structure to guide students who are at sort of the earlier stages of their degree programme on what to put into these reports. So I'll very quickly go through some of the different systems that we had a look at last summer. So the first one was this system called Indigo ELN. This is an open source version of a commercial product. It's very authentic in that it's actually the notebook which is used in Pfizer, but as a consequence it is very focused on basically the process in Pfizer's now, which is medicinal chemistry. And although it would be good to give the students some experience of what they might encounter in industry in terms of a teaching tool for general purpose labs, this was not very suitable. It's difficult to add feedback, for example, unless you're doing synthetic organic chemistry. The system is not really applicable. LabTrove was a system developed actually at the University of Southampton in the chemistry department. It's similar to a WordPress style blog with some added chemistry features. It's simple, but it's a bit restrictive. The student can post a blog post, the instructor can put comments at the end. It's also no longer being actively developed. eLab FTW is another open source solution. It's free. When we evaluated it, it was mostly text-based. There's quite a nice text editor, but it rather lacked features for classroom use, so it's rather difficult to add feedback. There doesn't seem to be much of a user community at the moment surrounding this notebook, so we were a little bit concerned about whether support and updates would be available in the future. So we also considered a few very general open source systems. So Media Wiki, I'm sure is something that everyone's familiar with. It's kind of basically the software which powers Wikipedia. So it allows very flexible online document creation. So basically anything you see in a Wikipedia page, a student could create using the Media Wiki software. So unfortunately the editing, it's kind of quite geeky. There's a kind of a markup language which you use to describe the pages, and we thought that would be a barrier for both students and staff. I would have to add there is a newer version which has a sort of a more visual editor available now. It also really doesn't understand the concept of sort of document submission. You can have comments pages, but in terms of actually submitting a piece of work for assessment, that is not built into this system. Mahara, on the other hand, is another open source portfolio system. This is already available and supported in Cardiff. It allows very flexible document construction, so a student can create a portfolio of documents. And unlike Media Wiki, this has been built with education in mind, so the student can sort of lock the page, submit it, the instructor can post comments on the page and then return it to the student. And so we quite liked this system because of those features. We also had a look at several commercial systems which seem to have been built more with education in mind. So there was Perkin Elmer Elements. This is a cloud-based system, so you log on through the web, and the documents are constructed through what the vendor describes as elements, which are, for example, a chemical structure, a results and discussion section, a methods section, a protocol section. There are some chemistry features built in, so for example the structure editor. We found the documents a little bit restrictive in that you have to construct them from these kind of pre-built elements. On the plus side, the user interface was quite friendly. It didn't take much to get up and running with this system. So the other commercial system we looked at was one called Lab Archives. Again, this is a cloud system. It was originally designed as a research lab notebook, but the company that produced it obviously realised that there was a market in teaching as well, and they have brought out a classroom package. So the actual lab book itself is very flexible. There are tools built into it for editing text. There's a chemical structure drawing tool built in. There's kind of a general sketching tool. You can accommodate spreadsheets. You can even link it up to your Office 365 for editing online. So it seemed like quite a powerful lab notebook, and it does have the advantage that it supports kind of classroom features, so you can create courses, create a template, send the template out to the students who are enrolled on the course. The students can submit their work, and then you can delegate the marking to teaching assistants. So there has been a bit of thought gone into this package on how it might be used in a kind of a teaching situation besides research. Obviously the downside is that it is a commercial product, so there is basically a per semester, per student subscription payment required. So we decided to take Mahara into a trial with a very small cohort of our MSc students on a practical module in biological chemistry. So this consists of 3 experiments, and in previous years the students have done this as a hard copy write-up of a kind of a journal-style lab report. And so this year we asked them to create these pages in Mahara as a portfolio of experiments, instead of kind of submitting this wad of paper, which they had done in previous years. So the experience was that the students initially had a few teething problems with the system. We had to give them a little bit of tuition on how to use it properly. So one of the problems was that students were creating pages kind of in a communal area rather than their personal portfolio. There are other sort of minor issues to do with the editor, so it's possible to actually create a page kind of in the page description rather than the actual body of the page. Again, that caused some problems, and there are a few issues with page layout. So we had to give the students a few pointers for to make sure they got the best out of the system. The actual results look quite nice. I mean, you end up with documents which are comparable with the sort of thing a student might be able to do in a word processor. So here's an example. We've got kind of graphs, text. The system doesn't support any chemistry specific features, but essentially, if you can generate a document with Word, you can generate something similar looking in Mahara. And it does have the advantage as well that the portfolio allows you to kind of group documents together to create a portfolio of experiments. So from the staff perspective, it was relatively easy to access the students' work, provided they had prepared it in the correct way. If they'd prepared the work in the communal area, that was a problem, because you can't see who has created what. So, giving the students some proper tuition on how to use the system, I think, was essential. The actual document viewer, looking at the documents online, was fine. It's as good as the tools you find in Turnitin and Blackboard. As far as giving feedback is concerned, I think the feedback system in Mahara is slightly behind the facilities available in Turnitin and Blackboard. So you're rather limited to posting comments at the end of the students' pages. So with a bit of tuition, again, I think we could improve the ability to add feedback. So the problem we had was that students would create their report as a large monolithic document, and then there's one comments box down the bottom, and you have to post all your feedback into that single comments box. So, in this particular example here, I've got comments, feedback on different sections of the student's report, and I would have liked to have actually attached these feedback items to the individual sections, for example, the results and discussion, but I couldn't do that because the student had combined the introduction, the results and discussion, the references, and the images all in the same box in their page, and so I was limited to basically pasting the feedback into this single box. And constantly scrolling up and down. So there were some sort of technological problems. Again, I think we could get around some of those by basically telling the students, please, put your different report sections in different items in your Mahara page, and then we can actually attach the comments, the feedback directly to those individual items. There are some other issues, I think, which would come up with large class sizes, and that there's no real integration with Learning Central. So if you were having to enter marks, we would have to put the mark into here and then put the mark into Learning Central or a second spreadsheet to keep track of it. So potentially some efficiency problems there as well. So to kind of summarise the conclusions there, the commercial systems, the lab archives we thought looked good in that it's very versatile, and it seemed to be sort of a nice bridge between a teaching tool and the sort of thing a student might encounter in industry or a research lab, but there are some cost implications. Whereas Mahara, we felt that would be a great tool for a student who was maybe doing a portfolio of experiments with different techniques, because it provides good opportunities for reflection. Students do need, I think, a bit of tuition on how to use it, and I would probably be a bit nervous about using this as a summative assessment tool, particularly with a large cohort of students, because I think there would be some potential inefficiencies there with handling marks and feedback for a lot of reports submitted this way. So I will wrap up at that point. So I'd just like to thank the CEI for funding us last summer, and Gethin for his assistance, and thank you for listening.